Hello friends, let's solve another Leetcode problem today. Today's problem is number of subsequences that satisfy the given sum condition. Let's go through the problem statement. We are given an array of integer nums and an integer target. Return the number of non-empty subsequences of num such that the sum of the minimum and maximum element on it is less or equal to target. Since the answer may be too large, return at modulo 10 to the power 9 plus 7. So you can go through the sample test cases, and these are the limits. So as you can see, the length of the nums array can be huge, 10 to the up to 10 to the power 5. So the brute force solution would have been to generate all subsequences and basically check the min and max values of the subsequences being generated, and if the condition is satisfied, just add to a result variable, or basically mm, add that to the count, add that subsequence to the count, and basically we would have got the solution like this. But the time complexity, since at every index we would have two possibilities, whether to take that element in the subsequence or not to take that element, so total number of possibilities would have been exponential. Basically the time complexity would have been something like 2 to the power so that can't be done since n is huge here. So we have to find a better approach. So in order to solve this problem, basically we have to observe that it's beneficial to sort the array, because suppose this array was not given in sorted order. So suppose this was given something like 6, 5, 3, 7, and, so the sequences that could have been generated would have been like, if we take 6, then 6, and if we don't take 6, then we proceed to uh, basically empty subsequence, but like that's not allowed. So if we take 6, then this is the possibility. If we don't take 6, then we can proceed with next element, next, so something like this. And if we would have taken 6 and 5 together, something like this, then something like 5 and 3, and so on. But the subsequences that are being generated here, so those would have been something like this: 5, 6, 7, and if we skip 3, then 5 and 6. So like if you observe this, like this and this is basically just in reverse order, but the min and max elements here are same. The min is 5 and the max is 6. So basically, we are getting the same subsequences just out of order if the array would have been not in order instead of being sorted. So basically, like, this gives us the hint that we can sort the array and then proceed to process this. So sort the array, that's the first step. Then suppose this is the array in sorted order. Then we basically know, like, suppose we were considering the two extremes, 3 plus 7. But this itself is greater than the target, so this should have been less than or equal to target to be considered in the result. So we can basically for sure say that anything, if there would have been numbers to the right of 7, they could have been skipped, because they would have also given us some which would have been greater than target. So we can basically, we could have skipped this section of the array, basically 7 and to the right hand side, and just consider this part. Now let's see 3 plus 6. So 3 plus 6 is 9, which is less than or equal to target. So we can consider this section. Now how many subsequences would have been there? Since we have to generate a non-empty subsequence, we are basically trying to fix, in this approach, in this two-pointer approach, we are trying to fix the L left hand side pointer element. So that would have been in the subsequence for sure, and we have to find out how many different possibilities exist with the other elements, because we have to generate non-empty subsequences. So here the right pointer was here, so let's write it down. R would have been 2. Here diff is 2 between R and L, so R minus L is equals to 2. So we basically have two possibilities in this diff number of elements. So the total number of subsequences basically would have been 2 to the power diff, which is 2 equals to 4. And we can increment the L because we were fixing L and finding out the possibility. So it's time to consider the next L value. So when 5 plus 6 is 11, which is greater than target. So this itself is greater than target. So we can try to reduce the right hand side element. 1 and 1. So 5 plus 5 is 10, which is again greater than target. So again, we have to reduce. But once we do this, we hit the condition that R is less than L, so we can break out, and because we know we have considered all the possibilities and exhausted all the subsequences basically that could have been generated. So basically, this is a two-pointer approach. So the time complexity would have been linear. So big O of n for the two-pointer approach, but before that we have to sort this array. So big O of n log n for that part. So total time complexity would be big O of n log n, and since n is less than or equal to 10 to the power 5, so this would pass. So let's code the solution out quickly. So let's sort the array first, then have two pointers R and L. So these would be at the two extremes of num. So let's have a result variable where we can keep on adding the possibilities and we can return it in the end. So that two pointer approach would go something like this. If nums L plus nums R is less than or equals to target, then we know that this condition is being satisfied, so we can calculate the number of possibilities by R minus L. So at each of these diff positions, we will have two possibilities. So we can add this by doing 2 to the power of diff, and since we have to take a mod, let's define that as well. So 10 to the power 9 plus 7. So let's do the mod here, and we can do L plus equals to 1 here, else R minus equals to 1. Yes. So this was simple. Let's try to run this. So as you can see that sample test cases are passing. Let's submit this. As you can see, we have passed all the test cases. So thank you for watching, and please share and subscribe if you like the content.